We're going to start our unit today by talking about direct, inverse, and joint variation. You may have discussed direct variation in the past. Direct variation means that the two variables have a linear relationship. So your equation looks something like this. Y equals kx. K is going to represent some sort of constant that represents the relationship between the y and the x. This goes through the origin to be a direct variation question. And what we're saying with direct variation is when x gets bigger, y gets bigger. And likewise, when x gets smaller, y gets smaller. So a funny representation of direct variation would be the longer you are in the shower, the more water you use. So shorter shower, less water. That's direct variation. Our next type of variation is inverse variation. Inverse variation is represented by y equals k over x. So in this situation, if x gets smaller, y gets bigger. And likewise, if x gets bigger, y gets smaller. And again, k is our constant that's going to help us to solve the problems. Joint variation would be when you have three variables related to each other. So in this case, it might be y equals k times x z. I don't know, I'm making up variables at this point. But the same thing with k being the constant. So let's see what some problems look like that involve this variation. So the first problem says y varies inversely with x. So I know right away I'm starting out with y equals k over x. And they give me one scenario and they ask me to solve. Once I use this scenario to find my constant, I solve for the missing variable here. So let's take this equation. If x is 8 when y is 4. So I'll plug in 4 for y, 8 for x, and solve for k. So in this case, I multiply both sides by 8 and get k is 32. So my equation that I'm going to use is y equals 32 over x. Then we come over here, find y when x is 2. So we plug in x is 2, and we find out that y is 16. And there's our answer. So if y was 4 when x was 8, x is 2, notice x got smaller, y got bigger. Inverse variation. But that's all we do. The next problem is another inverse variation. So I'm going to start with y equals k over x. If x is 3 when y is 8, I multiply both sides by 3 and find out that k is 24. And so my equation, every once in a while they just ask us for the equation, would look like this. Another way we could write this, because we know we're going to multiply both sides by x, you could say that x times y is 24. That's the same equation. So find y when x equals 6. So y equals 24 divided by 6, which means y is 4. So notice 3 times 8 was 24, my constant. 6 times 4 is 24. So they multiplied to the same constant. For direct variation, where we said y equals k times x, we solve for our k value and then we'll plug it back in for the second half. So 6 equals k times 2. So to solve for k, we're going to divide both sides by 2, and k equals 3. So the equation there is y equals 3 times x. So we can come over here and say y equals 3 times x. So when x is 7, y is 21. So the relationship here is a division relationship. 6 divided by 2 is 3, my constant. 21 divided by 7 is also 3. And we'll do a joint variation question. It says, z varies jointly with x and y. So this equation looks like this. Z equals k times x times y. We're going to plug in the information they give us, solve for k, and then we'll use that k value to solve for our final answer. So here we go. If z is 20, when x is 4 and y is 3. So that means 20 equals 12 times k. So I'll divide both sides by 12, and that's when you can grab your calculator if you don't want to simplify this fraction. And you could say, let's see, I'll do alpha y equals, get my fraction, 20 over 12. And that reduces to 5/3. So k equals 5/3. So now I'm going to come over to the second half of the question and find z. K was 5/3, x is 2, y is 3. So all I have to do is multiply those together, and I will find out what z is. So 5/3 times 2 times 3 is 10. So in all of these questions, we used the direct or the inverse, or in this case, the joint equation to solve for k. Once I know what k is, I can get my final answer. So we move to the next page. A car uses 8 gallons of gas to travel 290 miles. So if we think about this, the more miles we travel, the more gas we're going to use. So that's a direct variation. Another way to solve this is just with proportions. Remember, we could do miles over gallons. And I'd say, okay, I go 290 miles for every 8 gallons. How much gas is used to travel 400 miles over gallons? So this is one way to solve it. And then we just use our calculator. Let's see, 290 times x and 400 times 8 is 3,200. So when we divide both sides by 290, we get 11.03. So around 11 gallons of gas are used for this 400-mile trip. Now, another way to look at that, because that was pretty easy to do with just proportions, if you wanted to do the variation, you could say miles equals k times gallons. So I could have said, all right, if I go 290 miles for every 8 gallons, whatever 290 divided by 8 is, it's 145 over 4. I don't know, is that a nice number? It's 36.25 is K. And then I could go back to my second equation and say, okay, well then 400 equals 36.25 times how many gallons I'm going to use. And if I do 400 divided by 36.25, I get that same 11.03 for my x. So you could solve it with direct variation like we did on the front page, or if you recognize that, hey, this is just proportional relationship, you can use your proportions. All right, let's look at some equations and determine if we think they are direct, inverse, or neither. So remember, direct was linear, and it went through the origin. So take a look at number 6. It's linear, but does it go through the origin? No, it has a y-intercept at 7. So that's neither. The second one is x over 4. And if you wanted to, you could think of that as 1/4 times x, which means it's linear. 1/4 would be your slope. And there's no y-intercept listed, so it's 0. So yes, this one's direct. And then number 8, notice that x is on the denominator. That makes it inverse. So that's how we tell by looking at our equations. It's linear, but it doesn't go through the origin. We can't call it direct unless it goes through the origin. Now they gave us some tables this time. So if it's direct, remember we said y equals k times x. So that means my constant value would be y divided by x. We need to do division to check to see if it's direct. Inverse, because it was y equals k over x, we multiplied x times y to get our constant. So if they multiply to a constant, it's inverse. If they divide to a constant, it's direct. Let's give it a try. Let's see, 16 divided by 20. Let's try 40 divided by 50. Do you see a pattern? 88 divided by 110. I did something wrong. This was supposed to say 70 divided by 92. Well, let's get that right. 70 divided by 92. 72 divided by 90. Oh, gracious. There we go. I got 0.8 every time I divided. So 16 over 20, 0.8. 40 divided by 50, 0.8. 72 divided by 90, 0.8. So this was direct because they divide to a constant. Let's check this one. Now, if I start dividing to see if it's direct, let's see, 1 divided by 5, and then 0.5 divided by 10, those are not the same number. So I know it's not direct. Well, let's check to see if they multiply to a constant. 1 times 5, 10 times 0.5, 20 times 0.25, looky there, 25 times 0.02. Uh-oh. Looks like that's a typo. This should just say 0.2. So 25 times 0.2 there, and they all match. Okay, so ignore that one because it was a typo. So these multiplied to a constant, which means it's inverse variation. So remember in direct variation, we get the idea there. In direct variation, if x gets bigger, y gets bigger. So notice they're both getting bigger. Notice on inverse, x is getting bigger, but y was getting smaller. That's inverse variation. Now let's check this one. If I multiply these, I can do this in my head. 1 times 3 is 3. 3 times 27 is 81. All right, so I know right away it is not inverse. Let's try division. So this would be what? 3 divided by 1. And this one would be 27 divided by 3. I don't get the same number there. So it is not direct variation, which leaves us with neither. So that's what you check. If they divide to a constant, it's direct. If they multiply to a constant, it's inverse. If they don't do either one, then we put neither. And now I believe there's a practice page for you to work on.